Uh, Thank you. My name is Rajiv Goel. I'm product in charge, like part of the product team in Brookit for the routing products. So there has been some good sessions on the DDoS and other security, the topics over here. So what I wanted to share with you is the data privacy across the internet. Data privacy in simple terms means protect what's yours. So especially when you have, these large flows, content going across the internet, then what are the challenges, right? So that we are seeing and we are hearing. So wanted to share those findings with you. Go to the next slide. So in the data privacy, we are seeing like strong growing interest. There are a couple reasons. One is the data breaches. So you might be hearing, last year there have been data breaches for the traffic in transit and like on the endpoints, like on the POS terminals. And why are these data breaches happening, right? So data breaches are motivated by multiple things. One is the intellectual assets. It's almost like when you leave your home and you have your laptop bag with you, then what do you hope for? You hope for like, nobody takes it. But you know what is worse than somebody taking or stealing your laptop bag? Is somebody be able to take the data off. And so that is one of the primary motivations is similarly when you have data going across the transit, especially the internet, then intellectual assets, and then there could be like, your customer information on it. There could be the premium content. Content is king, as we know, right? So somebody taking your content away from you, I mean, without paying you, without any charge, I mean, that's not something that they own. Another key driver is the regulations. So which is, for example, in the infrastructure, you might care about your data center to data center, sort of like data privacy. But similar to you, so your customers have different drivers. Like for example, healthcare would care about HIPAA. Financials would care about the Sarbanes. And similar to that, PCI, and not only that, like, the media companies would care about probably protecting their content. So it doesn't say that, they have to have the security, but then given the nature of the business, that's how it's kind of, so it's getting there. In terms of the opportunity, encryption, yes, but then there are more. Few examples I would like to share. The findings is, for example, remote data centers. Another one is like you have, let's say, your layer 2 networks. So layer 2 networks, you have the fibers with your customers connected in, but what if like you can have them come across the internet sites till you have the fiber available? Remote caching sites can be another example. So going into the details of what to protect, that could vary. That depends on the nature of like the content and the business and your customers. It could be the disaster recovery traffic across the internet. Video has been growing, right? So if you're sending it from, let's say, one studio to another or from a distribution site to the different studios, it's going from 1K to 2K, and soon it will be going to 4K and 8K. So imagine the flow size going from, from sub 1 gig, several gig, to even probably like, 10 gig. Medical imaging, financial information are some of the other examples here. So the use case, what is the use case here? Use case is, imagine like you have 2 data centers and you have the bulk transfers, right? So we have the customers who are experimenting, so we see like the customers who are experimenting or the communities who are experimenting, like, so going from 1 gig to 10 gig to even 100 gig flows. Now, across the internet, you may not put 100 gig, that might be quite a bit, but what about like, going from sub 1 gig to like several 1 gig to like, so 10 gig, how do you get there? And it's not data center to data center. You could have the campus, you could have the remote stadium sites, you could have the branch offices. So it's all part of the same network. The important part here is that how do you connect them all together in, right? So because if you have these sites, then what can you do? What level of encryption, right? So and what is the cost of doing or not doing that? And that's where the challenges comes in, which varies by the network and the use case. But first one is there is a stigma, right? So the first question that we hear from the customers when they think about the data privacy is the impact to the performance. Performance is very important to all the operators, right? So every bit that they can ship out on the network without having to drop the performance is a plus. So there has been this stigma associated with the encryption is that if you turn on the encryption in your network, then the performance goes by at least 50% or even higher. So that is the number one challenge that we hear. So I wanted to share that with you. Second one is, what is the largest size of IPsec tunnel? So some of the operators are concerned about that, if they put the IPsec tunnel, like IPsec in their network, what is the largest they can get to? Can it scale to their requirements? Can it handle like 10 gig flows? For example, like inter-data center bulk transfers. So the data rates have been going up and up, and there is no stopping. So how much can you push? Like, what is the biggest flow that you can get to? The third one over here is aggregation hub. If you look at the use case, the scenario is distributed. Take an example of the brand sites. Let's say you have 20 brand sites with 1 gig each. So do you want a full mesh? Do you want every branch to have tunnels with other brands? Or do you want to be able to have all of them talk to each other? So how do you do it? So that requires the aggregation hub. So what should be the capacities of the aggregation hub? So that has been one of the limiting factors also, is that if you do 20 branches as an example of 1 gig, that would translate into 20 gig. But what if you want to go and continue to scale up to 200 branches? Then what would be the requirement? Because then you would have 200 branches coming in, and they want to be able to talk to each other, right? So that would translate into like somebody be able to handle 200 gig encrypted traffic. Encryption level. Encryption level has been very popular, like 128 bits has been out there. You can see the IPsec and other implementations. It's not new, it's a very popular mechanism. IPsec is a very pervasive technology. So it has been out there for decades, very well used, like into many networks with small, medium, large deployments. But what is new, what is changing, what is challenging is that is 128-bit encryption enough? So does it protect what you care about? And that's the reason. So how about AES 256? So that would be something like another challenge, like challenge number 4 that I would like to point out here. So something to think about when you're thinking about the data privacy across the internet. Last but not least, there could be many. When we talk about internet, it's not an easy thing because you would need several factors which play a role. But the last one that I would like to point out and share with you is the frame size. So what happens with these encryptions is once you turn on the encryption, it adds an extra header. So when you have 120 bytes of a packet size, your tax is going to be up to like 64 bytes. That means like your performance is going to be impacted. So that could make it very challenging, like with the small traffic or the small sizes. What if what can you do to basically mitigate that? How about 1500 byte packets, right? Or even higher. By doing that, what happens is that your tax is still same. It still stays at that extra header of up to 64 bytes, but as you increase the size, then that could be a way to reduce that tax and have the performance out of your network so that you have high performance network with encryption, just like you do with your 10 gig, 40 gig, and 100 gig network. So I don't want to be between you and your lunch, but if you have any questions, do we have time for questions? Okay. So if there is one question, please let me know. Otherwise, you have the email. We can talk offline or during the break, or feel free to send an email. Okay.
Thank you, Rajiv.
Sure.
Thank you, Tony. So I should say, or normally would say, thank you very much for coming, but maybe it would be better to say thank you very much for staying. But thank you also to the program committee for having me. I trust that I don't necessarily have to rush because we don't have anything following this except for the break, but I don't have a lot. This is some work in the true lightning talk mold where it's ongoing, it's not finalized. It's some things we were doing over the past 3 or 4 weeks, myself and a couple of colleagues at DePaul University, James and Mache. If you were paying attention earlier this morning, you probably would have heard something about NetConf. And if not, I'm afraid I won't have time to go over what NetConf is. But if I can get you to look up from your laptops for just a moment, how many of you actually have some NetConf running that you may or may not be using in your network, just by show of hands? A fair number of you. Okay, maybe a few dozen anyways. That's interesting. I assume most of you that raised your hand probably are doing it with Juniper gear, but would be my guess. And if not, I would like to hear otherwise perhaps after. And if you are, you'd have something like this in your config tree where you turn this on under your services. You may note, or you may be learning for the first time, that NetConf by default runs over TCP port 830. Now, if you're a user of the old Juno script, which is what this has arisen from, you could run that over port 22 as well, but people who are turning on this for the first time by default will have it over TCP port 30. And I didn't realize this until not long ago. In our network, we were looking at some other research stuff with multicast, and I happened to notice port 830 was open on router, and I said, what's that? And I had used Juno script before, but not NetConf, being somewhat newer. And then when we figured it out, we realized that it was on a lot of boxes, and none of us really realized that it was. Someone had turned it on for something. And so then we wondered, well, who else has this on? And do they know about it? And what sorts of potential issues might there be for those who maybe are unaware that this stuff may be turned on? Part of the problem for this perhaps being accessible on some networks may be our fault. We have this very old secure Junos template on our site that hasn't been updated. It's effectively outdated and stale now since a decade. In fact, a lot of the stuff that's in there was things that I had put in there before I even joined Team Cumry. That may mean it's partially our fault, but I haven't heard many people ask us about this template recently, so it may not even be used. But if this needs to be updated, I would certainly like to hear about it, so maybe we should do a new version of this because it's so woefully out of date. So we went looking, we scanned, one of the probes that we did is we just took 10 million random IPv4 addresses, and we said, well, who will respond to us on TCP port 830? And let's follow up that and see if we get an SSH connection. And just doing a random scan in the address space for that, we've actually found very few, not many at all. Some, but not very many. If you were in the security track yesterday, you may have noticed or saw Jared talk about being able to identify Junos versions using a particular protocol. If you don't recall what that is, that'll be your homework to figure it out. But we have a way to identify Junos boxes on the internet. So I took a sample of those specifically and then probed those, and we found at least comparatively higher percentage of boxes that do have NetConf listening. And some the versions of Junos running vary quite widely. In fact, some will be running SSH less than version 2 or version 1. Now, NetConf by default for an implementation has to run over SSH, but there's also an RFC that says you can do NetConf over TLS. There's also one that says you can do it over beep, but I don't know that anyone actually does that. But over TLS, so we said, well, and that's a different port, so let's take a look at that. Let's probe randomly, and we found some there, even a few more than we would have found over port 830 from a random scan. And those are actually kind of interesting. So I thought I would show you a couple of things that we found, and I hope you can see this in the back. And so if you're looking at your laptops, this is where you look up and you chuckle a little bit and make fun of AT&T. This is a box from AT&T that does have NetConf over port 830 open, but port 22 is filtered, so they're probably in the situation where they thought they were locking down the routers, probably enabled NetConf, and forgot to put a filter on their loopback interface for that as well. On the certificate side, so if you look at NetConf over TLS, we found a lot of interesting things here. These just pulling out some of the attributes of the certificate. Quite a few banks. I don't know what sorts of devices they are. We haven't done a terrible amount of investigation of this yet, but some interesting things, and you may note that last one, a .mil, people's eyebrows always tend to rise slightly when you hear about a .mil being exposed with something. That is, I don't know if that name matches the IP address that we had, but I can assure you that the IP address that that was associated with was a .mil address. So the stuff is certainly out there. Now, the question must be asked, well, is it a big deal? Is it, what's the threat here? How much of a problem really is this? And it may not be that much. I'm not here to cry wolf, and I would suggest to you, if we could sum this up, don't panic. But there may be threats, and so this is why we wanted to try to take a better look at this and bring this to your attentions. Perhaps with the SSH netconf, two of the things that I might be most worried about, if it were me, would be the ability to perhaps do a denial of service attack on that netconf service. Usually by default, your Junos boxes have a connection limit, and so if you could tie those up, whatever you may have doing netconf may not be able to get through. The other thing is, and probably more worrisome, is if you have weak passwords associated with an ID, some account on this box. We've certainly seen SSH brute force attacks in the past. We certainly don't want to see any more of them. So this doesn't necessarily make the problem really that much worse, unless those people who thought they were protected with their loopback filters don't actually have them protected. Now the TLS service, the certificate one, I think there's a fair amount of detail in the certificate that's quite interesting. I don't know if you would consider it high risk of that being exposed. But the one thing I'm not sure about yet, we haven't finished studying this, is that my fear is those systems that do netconf over TLS may not have strong authentication. You may just be able to attach to them and perhaps using generic ID and passwords do effectively anything you would be able to do via command line, but just using netconf. If anyone knows how this stuff works over some of these devices, and I'm not even sure all the devices that do netconf over TLS, but I'd be interested to know more about that before we actually start poking around a little further. So I'll leave you with some of the questions that we are going to try to answer as we do a little bit more of this, and some of these questions may be for you, and I won't read every one of these to you, but I would be interested to hear if you think this is worthwhile. Should we continue? Should we provide some sort of data feed like Team Cymru does for other things? Do you want to know about this stuff in your network? I'm pretty certain many of you here probably have some of this stuff. Maybe I just told you something about your network you didn't know once you go looking. So I'd be curious to hear any response to this, this effort and how much more time we should spend on it. And with that, I thank you very much for your attention and your time. I think that's Michael in the back.
It is, Mike Sinatra, ESNet. Keep in mind, this stuff also runs on IPv6 by default if you have IPv6 turned on your router.
Well, netconf isn't turned on by default, is it?
It isn't turned on by default. If you turn it on, it will go. So if you run like a Juno Space appliance in your network and you think you're blocking all traffic to everything but that, but you forget to put the filter in IPv6, it's the same. Okay. You're going to open IPv6 to the whole world. Okay. So I say this from experience, obviously. This is an obscure enough problem, but yeah, this stuff runs on IPv6 too. Okay. You need to make sure that your IPv6 filters match your IPv4.
Okay, thank you. Sir.
Lemin Alexander, Curator Labs. What do you think would happen exactly if CPU resources on control plane of your Juniper box will be completely exhausted, like 100% utilization?
What could happen?
Yeah, what would happen?
Well, this is somewhat not necessarily specific to netconf, but I suppose a number of things could happen. Your routing protocols may start dropping packets, so routing sessions may drop, all that sorts of stuff, right?
Unpleasant things will happen. So don't expose your control plane to public network, right?
I think that's part of that. I think that's part of what I'm saying, yes.
That's it.
Okay. I think we're finished. Very good.
Thanks very much.